Hey, 42 here, and welcome to Schierbeek, one of the 19 municipalities of Brussels. On the 18th of May 2003, Schierbeek held a local election using electronic voting machines. All was going well until the votes were counted, and it was noticed that one candidate received 4,096 extra votes. That couldn't have been possible, considering the total number of voters that attended. This wasn't just a small anomaly, this was a major hiccup. Something had gone seriously wrong with the vote. There was a large investigation, and the electronic voting machines used in the election were thoroughly checked over. Even the source code for the software was scrutinised to try and find a bug that would explain 4,096 votes out of nowhere. But it wasn't a software bug. It was caused by something that nobody could have anticipated: a charged particle from outer space. Several hundred light years away and hundreds of years ago, a star exploded in a galaxy far, far away. This violent supernova emitted cosmic rays, trillions of highly charged particles of matter. They will travel through space indefinitely at close to the speed of light. But one of these particles set out on an epic mission, a lifelong goal it was determined to achieve: to disrupt the Belgian local elections of 2003. This tiny terrorist travelled through the inky black for hundreds of years. It finally reached planet Earth, and in a show of defiance penetrated its magnetic field before slamming into a microprocessor in the core of an electronic voting machine in Brussels. This caused a single bit within the computer's memory to flip from a 0 to a 1. This is known as a bit flip, and thus a spectacular chain reaction happened within the computer's code, which caused 4,096 votes to materialise from absolutely nothing and register themselves against one particular candidate. If this error hadn't been noticed by the officials, the wrong candidate would have been elected that year. But this isn't just some super rare event. Planet Earth is constantly being bombarded by trillions of charged particles from outer space, and your electronic devices are continually at the mercy of this radiation. Have you ever been trying to finish up an essay, and just before you hit save, your computer freaks out on you and you receive the ominous blue screen of death? In many such cases, it may have been caused by a charged particle from outer space hitting your computer's processor and causing a total system crash. But it's not just antiquated Windows machines that suffer from tiny invisible space invaders. Galactic particles cause errors, bugs and crashes on your smartphones, smartwatches, tablets, televisions, and terrifyingly, even your car's onboard computer. In fact, such events are so common that they have been given a name. They are called single event upsets, or an SEU. They have been giving computer engineers and developers a major headache since the dawn of computer processors, forever causing completely inexplicable issues and crashes that just shouldn't have happened. We could just ignore the issue. After all, we've put up with it for all this time. We just get angry when it happens, slam our keyboard against a wall, and continue our day acting as though a slight computer glitch didn't just get under our skin and cause us to flip the hell out. But we simply can't ignore SEUs, because they can be deadly. In October 2008, Qantas flight number 72 was mid-flight on the way from Singapore to Perth Airport in Australia, when suddenly, with no warning whatsoever, the plane's autopilot system disabled itself, causing the plane to freefall rapidly for 23 seconds, before pilots managed to regain control and safely made an emergency landing. 1/3 of the passengers were seriously injured due to the massive G-force suffered from the sudden freefall. A lengthy investigation took place, and it was discovered that the autopilot was turned off by a computer error caused by an SEU. The most likely explanation is that a highly charged particle from a cosmic ray trillions of miles away in space had hit the computer's processor, wreaking havoc. The higher up in the atmosphere you go, the more prone your electronics are to SEUs, because many of the particles entering Earth are stopped before they reach the ground. This means planes are particularly at risk. Whether we like it or not, our world is run entirely by computers. Our bank balances are simply bits on a computer hard drive. Our cars park by themselves and will very soon drive themselves. Computers power the vast majority of conversations that take place every day across the globe. Every piece of information we now receive comes from computers, and they also influence every decision we make. So, in a world so dependent on computers, it's only a matter of time before an invisible cosmic particle causes an SEU somewhere in the world that completely disrupts a major computer system. The fallout of this could be enormous. Just imagine this scenario. A charged particle causes an SEU on a major federal server in the US, causing the banks to collapse and the GDP of the United States to drop from $18 trillion to $18 overnight. Trump could finally lose his shit and nuke the world over one tiny atomic particle. Okay, I may be hyperbolizing, but it could happen. Maybe. So, what do we do to defend against these atomic anarchists? Well, we already are, and we have been doing so for almost 3 decades now. In the early 90s, IBM and some other computer manufacturers realised that they had to come up with a way to make computers more reliable if they were ever going to sell them en masse to consumers, and even more so to businesses who needed servers that they could rely on 24/7. So, a few tech companies came up with the idea of parity. Computers speak in bits, it's their language in its most primitive form. A single bit is the smallest unit of data in a computer, and it can either be a 1 or a 0. Put all these bits together and suddenly you have words. For example, this may look like utter nonsense to you and I, but to a computer this reads as nobody expects a Spanish Inquisition. Take the first 8 numbers, 01001110, which translates as N. This group of 8 bits is called a byte, but all it takes is to change the last digit of this byte from a 0 to a 1, and its translation changes completely from an N to an O. Now, this is where parity comes in. Computer scientists had the genius idea of adding a 9th digit to the end of every byte, an extra 0 or a 1. This extra digit is called a parity bit. If all 8 digits add up to an even number, then the parity bit will be a 0, representing even, and if not, then a 1 is added, representing odd. And therefore you know it's a valid byte in just a glance. If a byte is received by the computer's processor that adds up to an odd number, but the parity bit is a 0, suggesting it should have added up to an even number, then the computer instantly knows that there's an error in the byte, potentially caused by an SEU. This works brilliantly, but you see, merely detecting errors wasn't enough, because it's not just cosmic radiation from outer space that causes computer errors. They are also caused by nearby magnetic fields and the ionizing background radiation of the Earth itself. Even the temperature of the room the computer sits in can create software hiccups and cause crashes. So, people with really long beards, because as we all know, you're not a proper computer scientist unless you have an impressive beard, ladies excluded, took parity bits one step further and invented a genius way for computers to not only detect when an error has occurred, but to self-correct it. And so ECC memory was born, short for error correcting code memory. When an error is detected via a byte parity bit, the ECC memory goes back to the code that created the byte in the first place and double checks everything using special algorithms. Once it has discovered what the true value should have been, it simply corrects it quietly and gets on with its life. And the human sitting behind the screen is none the wiser that the computer just saved them from a blue screen of death and a whole load of stress. So, if this miraculous ECC memory exists, then why does my computer, smartphone and tablet still crash occasionally? And why are planes falling out of the sky randomly? Well, ECC memory is slightly more expensive than regular non-ECC memory, so most consumer computers are built with non-ECC memory, meaning they can't self-correct. ECC memory is typically used in mission-critical applications, for example by banks and in server farms, where absolute reliability is essential to their business, and a minute of downtime could literally cost millions of dollars. And yes, I know what you're thinking. They didn't think that the lives of hundreds of humans on a plane didn't warrant ECC memory, yet financial trading does. Yeah. Don't worry, since that incident, the reliability of onboard aeroplane computers has been significantly improved. But even with ECC memory in your computer, you're still not immune to crashes. Far from it. It can protect you from cosmic rays and radiation, sure. But some crashes are simply caused by poor and shoddy programming or software that's riddled with bugs, and there's plenty of that to go around. So we found a solution to cosmic ray bombardment here on Earth. But the problem is 1,000 times worse once you leave Earth's protective atmosphere. Out in space, the amount of cosmic ray abuse one suffers is many thousands of times higher. Apollo astronauts reported seeing a streak of white light across their field of vision every 3 minutes whilst out in space, even when they closed their eyes. It was explained to them that this was caused by cosmic rays hitting their optic nerve, causing it to temporarily glitch and crash. As you can imagine, cosmic rays play havoc with satellites and spacecraft, but they can also save them. In 2015, the privately funded space exploration program, the Planetary Society, launched a groundbreaking data-gathering spacecraft into space, called LightSail, that would use a large reflective sail to propel itself through space using photons emitted from the sun. An amazing idea, but soon after it reached outer space, the onboard software crashed and LightSail ceased all communication with Earth, rendering it useless. The engineers back on Earth knew that the crash was caused by a memory leak, and all that was needed was a total system reboot to get it working again. See, even rocket scientists fix their computer issues by turning it off and back on again. For 8 days straight, the spacecraft drifted through space, completely dead. The engineers had almost lost hope, when suddenly a cosmic ray from a galaxy many millions of miles away hit the onboard microprocessor in just the right place, which caused the software to reboot itself. The engineers were amazed that suddenly they were receiving messages once again from the craft. A random cosmic ray had caused an SEU and saved the day. There are over 4,500 artificial satellites currently orbiting Earth, and they are crucial to our everyday life in the modern age. We use them for navigation, to predict the weather, for business and finance, communication, television, and many other uses. It's therefore of the utmost importance that they don't crash on us. They use a multitude of techniques to achieve this, such as physical shielding using thick heavy metals and ECC memory. NASA, however, were so concerned about the threat of cosmic rays upon their spacecraft's onboard computers that they devised a devastatingly simple yet enormously effective solution to solve the problem once and for all. Instead of putting one processor chip inside the craft, they put 3 identical chips in there. When the computer needs to calculate something, it is calculated on all 3 processors simultaneously, and the results are compared from each processor. If one processor produces a different result from the other 2, then the computer knows it's wrong. You see, the likelihood of a cosmic ray causing an SEU on one processor out in space is quite high, but the chance of it happening on 2 or more processors at the same time and causing the exact same error is vanishingly small, if non-existent, making the 3-processor solution extremely reliable. Which just goes to show that sometimes the most complex of problems requires the simplest of solutions. Thanks for watching. I'm really excited to announce that you can now get a high quality 42 t-shirt, mug and poster every month by simply heading over to patreon.com/42 and becoming a patron. I will be designing a new t-shirt, mug and poster every month based on videos that I've released that month and sending them out to my patrons. And not only will you get some awesome rewards in the post each month and early access to all my videos, but you'll also be helping this channel to make better videos through your support. So thank you.